So recall, for permutation notation, the expression is n choose, the permutation of n choose r. So this is where order is important. It's a permutation, and out of a set of n choices, we're going to choose r of them. So that's the number we're going to select out of the total we have available. So for this permutation, permutation of 7 choose r, we're going to write this. The general form is n factorial over n minus r factorial. So if we sub in, here n is 7 and r is 7, so this will be 7 factorial all over 7 minus factorial, which is equal to 7 factorial over 0 factorial. And 0 factorial is just 1. So if we do 0 and then factorial, we get an answer 1. So this is really 7 factorial divided by 1, which is 7 factorial. And if we're asked to calculate this, so if we go to our calculator, it is 5,040. Now the next one, if we have 8 items to choose from and we're going to pick 5, and we want to know how many ways we can do that if order is important, then this is going to be then 8 factorial divided by 8 minus 5 factorial, which is equal to 8 factorial over 3 factorial, which will be then, if we, I'm going to go through how this works. So 8 times 7 all over 3 times 2 times 1, and the 3's cancel out, top and bottom, 2's and the 1's. So we're left with 8 times 7 times 6 times 5 times 4. Now, if we use our calculator for this, 8 factorial divided by 3 factorial. And if you multiplied all this out, you get the same answer, which is 6,720. Right, so if we're asked to write in factorial form, okay, this is just where you're going to write it without, where it's unsimplified. This is going to be n choose r, so it'll be 6 factorial all over 6 minus 4 factorial, which is equal to 6 factorial over 2 factorial. And so if it's in factorial form, everything will be expressed as a factorial. This one will be 15 factorial all over 15 minus 6 factorial, which is 15 factorial over 9 factorial. Now, if we're asked to do this in factorial form, then I'm going to rewrite this it's 3 times 2 times 1 all over, and we want to get rid of this, so this is 8 factorial in the numerator, so I'm just going to write that down here, 8 factorial. Now to get these to cancel out, the 4 times 3 times 2 times 1, I'm going to divide by 4 times 3 times 2 times 1, and that is 4 factorial. So our answer then, to express 8 times 7 times 6 times 5 in factorial form, it's 8 factorial over 4 factorial. So in D, if we write n factorial, okay, that's going to be n times n minus 1 times n minus 2 times n minus 3 times n minus 4, etc., till we get to 2 times 1. So we need to cancel out everything after this. It would be n minus 4, n minus 5, and so forth. So we would write n minus 4 factorial. And then everything else will cancel out afterwards. Okay, next question, we have to express in the permutation notation 6 factorial. Well, we could write that as 6 choose 6. And this would be 6 factorial over, when it simplifies, 0 factorial, which is 1. So we're going to write 98 times 97 times 96 times 95 in factorial notation. We could write 98, and then it'll be 4. Choose 4, because we're going to select 4 items out of this 98. If we expand this, this would be then 98 factorial over 98 factorial, minus 4 factorial, which would be 98 factorial all over 94 factorial. So that means that this would be 94 times 93, and so all of the 98 factorial will cancel out except for the 98 times 97 times 96 times 95. And if we're going to write this in factorial notation, this would be the same thing as 18 factorial over, and in brackets, 18 subtract 6 factorial, which would then be the permutation of 18 choose 6. Right, now a problem here where there are 12 people on a swim team and 4 will be chosen to take part in a relay racing in a given order. So the order matters here, so this is a permutation. In how many ways could the 4 swimmers be selected? And so one way is using fundamental counting principles would be equal to the number of ways would be 12, because you have 12 people to choose from for the first part of the first order, or to swim first. Then you have 11 people to choose from to swim second, 10 to swim third, and 9 to swim fourth. Okay, so that's using fundamental counting principles. So that's method 1. Another way you can do this is by using permutations. So if we're going to have 12 people, and we're going to take the permutation of 12 choose 4, because we're picking 4 people to swim. Well, this is equal to 12 factorial over 12 minus 4 factorial, which is equal to then 12 factorial over 8 factorial. Now, this would be and so forth till you get to times 1, all over 8 times 7 till you get to times 1. And so all this will cancel out, and all this will cancel out. So the permutation of 12 choose 4 is equal to 12 times 11 times 10 times 9. On the calculator, I can do this as 12 12 factorial divided by 8 factorial, and you get 11,880. So there, therefore, are 11,880 ways to choose the 4 swimmers.